Hello, everybody, and welcome to FYI, Ark's 4-Year Innovation Podcast. We're super happy to welcome Shyam Sankar, the CTO of Palantir, on the show today. Shyam, thanks for joining.
Yeah, thanks for having me.
I think it'd be great to start off just to give our audience, our listeners, a little bit of your background and how you really found Palantir and how you've seen the company change over time. Because I think if my research is right, you were the 13th employee at the company and have been there for quite some time. So I'm sure you've seen a lot over the company's life.
Yeah, I joined Palantir 18 years ago, roughly as the 13th employee, and really the first person who built out the team that subsequently became known as the Forward Deployed Engineering Team. So working with customers in the field to really almost solve through back propagation what the product ought to be based on the empirical truth of what the problems were that they were facing and the answers that they needed. But I came to Palantir because of the mission. You know, I grew up as a child, essentially, of refugees. We fled violence in Nigeria, and I was raised with the immense gratitude of understanding the counterfactual every single day of how lucky I was to be in this country. My uncle was a victim of the 13 coordinated train bombings in Mumbai in 2006. And so I could think of nothing more impactful and important than working on problems related to national security in some way, shape, or form. Of course, the business has grown to be something much bigger than that, but I think that the fundamental driving ambition of solving problems that matter, understanding that the technology we're building has an impact on society, so you should own that and think about that in a normative way, has always been there as we scaled the business from government to commercial and beyond.
I was just going to ask quickly, Frank, Shyam, I remember first hearing about Palantir and the way it was described to me or us at Ark. It might have been my prior life, but it almost sounded consultant-like to me when we first. And then I looked at your gross margins and I said, this is no consultant. But I still think that misperception is there. I don't know if you find that when people are trying to explain what Palantir is and what you do. Can you talk about that misperception and how you are able to help people understand what exactly you're doing?
Yeah, it's a great question. And certainly, I think one of the most common misperceptions of the company. And I think a lot of it is how we present ourselves in terms of our product development strategy. Now that the term is much more often copied by other companies for deployed engineering. But the concept of that was really like, what is the likelihood that, sitting in Palo Alto, eating blueberries, we're going to think of the exact problem that our customers have in these very specific domains? Like, what is our access to truth? Is it here in headquarters or is it out there in the field? And what is our product development methodology going to be as a consequence of that? And our idea was that we actually need to go walk not just a mile, but many miles in the shoes of our customers to understand not only what their problems are, but the deeper secrets that in some sense their current problem is symptomatic of, and then go solve that root issue. And so there's a process of both discovery and product development in doing so. And I think the conceptual metaphor you can think about that is actually, how do you train a neural network? You start with the answer and you back solve, you back propagate to train the function. So similarly, how do we develop our product? We go figure out what are the deep, fundamental, unsolved problems that exist out there in the field, and then work backwards to the solutions around that. And I think that's also given us a sustainable edge in how we do R&D. You can kind of think about it as the set of things that are discoverable sitting comfortably in headquarters have been discovered. But as fancy as your ERP system is, when I go to the front lines of these factory floors, they're running on Excel. So if the ERP system works, why are they running on Excel? And who's spending their time thinking about that question? And can you go solve that? Can you build the product that addresses those issues? And so absolutely, I guess this is a long way of saying we can present like a consulting company, but we're not billing for hours. The model is not actually services. The model is to go figure out the profound problems that affect our customers. And you can see that in the early way in which we went to market, which was like really people would call us with a problem to solve. Tom Enders needed to fix the A350 ramp in the initial production, right? He's not a technology buyer. He has a really profound business problem that needs to be solved. How do I get my ramp back on track? I was supposed to produce 50 planes in my first year of production. I'm on track to produce 16. I've got 6 months left to go in the year. And certainly, now you have to go say, well, how do I go sit at the final assembly line in Toulouse? How do I go understand what's going on in Saint-Nazaire? How do I pull this all together and understand the parts of this that are technical, that involve data not flowing between institutions? How do I think about this institution as a web of decisions? From the hand of their supplier to the hand of their customer, they're making a bunch of decisions. Those decisions are all connected together. We've organized as a society, we think of these companies, we've broken them down functionally. This is your function, that's your function. Those functional divisions are a manifestation of how we're dealing with complexity. Well, no one person could make all of these decisions, but actually software can really help you do that. It can help you understand when I'm making one decision close to my supplier, how does it affect the customer? When I make these decisions, what options am I losing? What options am I gaining in terms of how I can deal with this problem? To make that less abstract, a kind of a simple example that's real, if my procurement person is incentivized based on the KPI of raw material costs, and my production person is incentivized on yield, you have a problem where the procurement person might be buying the cheapest possible good that has a lower net yield than a more expensive raw material. And this is the sort of canonical problem if you play it out over a more complicated value chain, where it's not only that the left hand doesn't know what the right hand's doing, the left hand is actively hurting the right hand. And so how do you connect these decisions up so that your company can be better?
Thinking about that approach that is so kind of tailored to the specific problem that your end customer has and working backwards to solve it, how do you still take those learnings and evolve kind of your core product and platform so you've kind of like, I assume, accumulated this knowledge and baked it into the core product that you're bringing so you're not reinventing the wheel all the time? How do you make it extensible and kind of more of a platform than it is a point solution?
Which your gross margins would suggest that you have.
Exactly. I mean, that's the art of it, right? I wish there was some science to that, but actually, when you engineers, we kind of like to think in abstractions. We like to look at the problem, think about the primitives. How does what I'm solving here apply to other problems elsewhere? And that is the art of product development in this context. But a very real example, like the work that we did to power Operation Warp Speed, the US and actually even the UK's COVID response, that initial work was inspired by what we had done optimizing hydrocarbon production for an oil major. And you can't actually, I think, fully connect the dots prospectively. Like, I didn't know that the work that we were doing in energy was going to be what powered the future of supply chains broadly. But I could say that, hey, solving this really hard problem, doing it in a way that generalizes, has nothing to do with energy. It's really grounded in data and how we ontologize that data. Historically, that's been an excellent bet for us. That is going to be something, first of all, I know it generalizes from a product perspective, and it's going to be the type of problem that other people find immense value in.
So this means you can go, whereas you started with national security, defense, and so forth, you can go into any vertical, is what you're saying, because of these generalizable approaches to solving problems.
Exactly. And that's what we've done. We're now in over 50 different verticals outside of government. And in government, it's not just intelligence, defense, it's also healthcare, it's also tax, it's all the basic functions of a government. And within the private sector, it's everything from energy and mining to financial services and insurance to healthcare and consumer packaged goods. The industries couldn't be more varied. But if you really, it's the same platform across all these industries. And that's what we kind of honed. If you go back to the very beginning in national security, I think the cynical way to think about Palantir is that it took something as sexy as James Bond to motivate engineers to work on a problem as boring as data integration. And that was really the first secret that we discovered, which is like, when we approached the space, we wanted to work on, I would say, sophisticated analytics that helped you find the bad guy. But that approach presupposed that you already had your data integrated. Mm-hmm. And if you ask people, they would tell you, yeah, I've spent, $500 million. I've integrated my data. It's here. But if you actually go to that system, you would discover it's not integrated. Like the real secret is that people were trying to solve data integration as a services problem. I'm going to hire an army of people. I'm going to integrate all of my data. It's going to be in one place. And then the job's done. Rather than recognizing fundamentally it was a product problem. Because not only is the volume of data you have growing every single day at an exponential rate, the number of discrete data sources is growing. So every day at the margin, there's more data to integrate that you hadn't conceived of with your services-led approach. So you need a product that was capable of keeping up with the entropy of data in your enterprise. Having solved that problem, Now you can do lots of things with it. Now you can actually go on and you've earned the right to do the sophisticated analytics. And the translation for that in the commercial world is agility, right? Like when everything was in steady state, people didn't really perceive that they had a problem. You needed something like the A350 ramp up or some sort of event to catalyze that. And I'd say with COVID, everyone, certainly anyone that touched supply chain, experienced a simultaneous shock that got them to really wonder, like, what over the last 10 years of IT investments, what have I been investing in that actually met its moment when we got shocked? And that was a kind of a sobering realization for a lot of folks.
Gosh, just on the data integration, in speaking with your chief revenue officer, I believe some time ago, he definitely pointed. So you've been doing that from the beginning, which positions you beautifully for what is happening today with generative AI. Are we right on that?
That's exactly right. Now that you have your data ontologized, which itself didn't take a very long time, I would say it was a rewarding exercise to go through, the ability that you can deliver these generative AI use cases, like the speed at which you can do it is phenomenal. I'm thinking about a large European insurance company that built a subrogation claims agent in 2 days on top of the ontologized data asset that they had in our software, or a warranty claims copilot that we built for a US auto manufacturer in less than 2 weeks. On top of their data. So the speed to value there is amazing. And so if you think about the warranty claims copilot, it saves 4 hours a day for their analysts. So half their day is now been reclaimed in a matter of 2 weeks. So the ROI on these things is truly incredible.
How long does it take, sorry, Frank, just to get our bearings here, how long does it take? I know it depends on the size of the organization, but how monstrous of a task is integrating all the data in, let's say, a decent-sized company?
Not as long as you would think. So I think one of the fallacies that's out there is really this going forward from the data. It's very, very tricky. So if you think, you end up boiling the ocean. So if you're like, look, I need to get my data house in order first before I can do anything, you will find that you never get your data house in order. Or to the extent you do, you might be kind of tricking yourself into thinking the job is done. The approach that we've seen be highly successful is working backwards from the decisions. So the kind of internal mantra we have is decisions, not data. Let's focus on the decisions that matter this institution. Now, from there, I can tell you what data can I bring to this decision that helps you make a better decision today and get into a learning loop tomorrow. No decision happens in isolation. So now I can look at the decision before and after that, and I can ask the same question. What data is involved with that decision? Now, this gives you a very clear priority function to go after building that ontologized data asset where every single day, literally, you're making money doing it. So it's rewarding. You can stay motivated through it. It's not some sort of, hey, just trust me. I got to eat these vegetables for 2 years and then I promise you money falls from the ceiling, which never really seems to happen. But look, every day I can validate that I'm on the path and the incremental work we're putting in has ROI from the business. And even more importantly than that, I'm learning. I'm learning about how we as an institution get better. And so that also catalyzes the very productive and generative relationship between tech and the business, which historically sometimes gets broken because the time horizons for delivery are very different. Business wants to know, what can you do for me today? And tech's like, look, if you only had a long-term view and invested in this, give me 2 years. I promise I can deliver the world for you. And regardless of which one is correct, how do we solve this mismatch? We find something, there's common ground, and that I can deliver for you today and I can deliver for you tomorrow.
So if we unpack that a little bit more, kind of starting decision first, then finding the right data to plug into it. You mentioned ontology a few times. What does that really mean, and how does that approach differ from maybe data warehousing or aggregating data in some other way? How is that ontological worldview shaped how you've built products at Palantir and led to, if I'm interpreting this right, a quicker time to value by using an ontology methodology, and then also how that sets up companies to action and deploy AI more effectively than other approaches?
Absolutely. So we think of the ontology as kind of the nouns and verbs of your business. It's not just the data model, which you could say roughly are the nouns, but also the actions that can happen. And so the ontology is this operating system layer that orchestrates your enterprise. So if I want to allocate inventory, I need the noun of the inventory, the parts, et cetera, the model for that. But even more importantly, probably an ERP system is my system of record for that. So I need the verbs. I need the ability to actually reach into that system and allocate the inventory. That's where it's going to happen. So now scale that out to all the transactional systems I have in the enterprise. So I have a model of the enterprise that represents how I, as humans, think about my business, not how that transactional systems schema happens to have been structured. My view of inventory might actually be informed from tens of different systems. So I have some sort of canonical way of seeing it as one thing. And then I have a single place I can go to actually permute that, to take action on it, whether I'm allocating it, reallocating it, assigning it, moving it into production, reassigning the customer orders, all the things I might want to do to it. I don't need to know I do that in this system or this system. It can't be done. Actually, I'm pulling it all together. So if you have that scaffolding, suddenly when you're analyzing something, you're able to go beyond dashboards to applications, because I can make decisions in the same pane of glass that I was otherwise generating insights in. That's where now you can apply AI to this. Okay, well, how was I analyzing it? Now I have a canvas across which I can bring the latest AI and actually very cleanly tie this to an action that changes how my business runs today. And all this is happening in the framework that gives me a continuous learning loop, right? We think of data not as exhaust, but as fuel. So all these decisions I'm making are being captured. I can see them in the context of the value chain. I can reflect on which ones were good decisions or bad decisions. I can make different decisions as my priority function changes. Maybe one day I'm interested in maximizing revenue. Another day I'm interested in preserving market share. Another day I'm interested in profit. Like my objective function, that's going to come as a function of the strategy from the C-suite. How do I tie my strategy to my operations that informs the decisions we actually make through that value chain? That's the value of the ontology.
And I think a key part there is the ability to actually take action on it. You can't just read the data and get analytics and maybe even make predictions. Or that's all great, but if you can't take action on it, then you can't actually move along a process within the organization to actually get to that end result that you're looking for. And I think that's what's unique about the Foundry, or generally your approach.
I think that's right. One CEO I know said, I want to be better, not just smarter, right? And in fact, he would have rather been better and not smarter, just kind of showing you the latent frustration he felt on not being able to take action on really clever insights.
And I think it naturally leads into like how you can help companies deploy generative AI, where everybody can look at the success of ChatGPT and how profoundly capable it seems at first when you're asking it questions and it's responding like it's an expert, and it can draft a newsletter for you, help you create a marketing campaign. But then how do you actually plug that into a process in an organization and take it beyond just this kind of like chat window? What does kind of operationalizing AI really look like?
And just to add on to that, did this shift towards large language models interrupt your business in any way, or you were anticipating it and, welcome to the breakthroughs?
I'd say we always viewed the ontology as something very important, as a key strategic differentiator. It existed in the first version of Gotham, this notion of the dynamic ontology back in 2003, 2004. I think we were pleasantly surprised to see how much the world we had been building for met its moment with LLMs. It's like, wow, you actually cannot unleash the value of an LLM without these things. That's been our observation, and why we've been able to move so fast. And maybe even to just take a step back to a lot of the stuff that you were saying, Frank, I would say it interrupted us in the sense that, by January, it was quite obvious that we needed to tear up all our roadmaps and get excited about how we could incorporate LLMs into our software to provide a whole new series of experiences, given where the technology had gotten to. And that we'd be positioned to do that because of ontology. So to take a step back and kind of think about what is the LLM doing? Because of course, chat has captured everyone's imagination, but I might go so far as to say I think chat is kind of an anti-pattern, or at least certainly limiting in terms of the value that you can unlock from LLMs. And we could kind of say, well, what is the LLM doing? I think it's actually really hard to say what it's doing, but I can tell you what it's not doing. It's not doing human thought, and it's not doing algorithmic reasoning. It's some sort of third type of compute that is some middle ground between these things. And when we look at it, certainly through a chat interface, it's very easy for people to think it's doing human thought because it speaks in the form that we'd previously known most human thought through, natural language. But it also doesn't really know what it's saying. And on the other extreme, it's clearly not capable of algorithmic reasoning, a form of execution so precise that if the same thing didn't happen every single time, you would call that a bug. But it does seem to be instructable in ordinary prose. And so the kind of conclusion we've come through working through this is that all of the value comes from an elegant integration of human thought algorithmic reasoning, and the LLM. And that's kind of the pattern. So when we think about AIP and what we've built here is like, how do I bring that to my customer? And to make that concrete, LLMs need tools. We all understand they can't do math. You take 5 LLMs, you ask it to multiply 5-digit numbers, each one will give you a different answer. You can say that's an LLM hard problem, but they don't need to. Orbital simulation, inventory reallocation, linear programming. We have tools that do these things. You need a tool bench or a tool factory to make new tools that gives you an easy scaffolding to pass these to the LLM to use and execute. All of the value in actually using these things, I think, comes from the application layer, which I think when you look at the market, you can see the people who've jumped on this fastest own the pixels at the application layer. And how do you bring the experiences to that? I think the reason that chat is also a limiting interface is it pushes us to expect the models to be domain experts. And if you go down that route, and you'll spend all your time thinking about how do I train a new foundational model? How do I fine tune models? And I'm not saying that there's a place for that, and we can get to that. But I think that gets you to undervalue is the parametric knowledge of the model is not useful for your domain. As in, what does the model know? More importantly than getting the model to speak English, which of course it does quite well. Actually, I think a lot of the value rests in getting it to speak code. And if you will allow me the colloquialism, to speak clicks, to speak a JSON or a DSL that represents your application state. So how do I take the current application state, the intent of the user, maybe with no prompt, and generate the future application state from that? They are very good at this. Yeah, and that's, I think, the secret of driving these experiences.
Is there a world where the model gets so good at talking to these applications that you can actually, even though pixels are important and the tools that have kind of this front end distribution, like I'm thinking of Photoshop, all of a sudden you can do really interesting and creative things in it. Is there a world where those types of UIs actually get displaced because the models get so good with a simple natural language input?
I think that world could exist. I think that it's much more likely. So if you think about like how our experience iterating with these things is that actually the LLM is a great way of accomplishing the first 95% of the workflow. And that you're going to want the escape hatch of being able to do the last 5% with a few clicks here or there in a canvas that you understand pretty well versus having to reattack it and try to explain what you're trying to do one more time through it. And that's a way in which I think the advantage accretes to the incumbents who own those pixels today. I do think, though, there's an opportunity for people who own the application space to integrate with other products in completely new ways. You could say, like, at the limit, conceptually, the LLM now means that the capabilities of your software are defined by the quality of your backend APIs and how strongly typed and type safe your data model is. The more that these things have excellent capability, the more you can actually rely on the LLM to get right. You could actually define your UI at runtime and have a fair degree of confidence that it's going to do exactly what you want based on the fact that your APIs are robust and cover the breadth of your ecosystem, and your data model allows you to validate the correctness of what's actually going on here. And that's what we've seen, that we've been bringing these generative experiences to the Defense Department in an application called Gaia that's used for mission planning. And so the ability, Gaia has maybe a decade of tools built into it. How do I do route planning? How do I do line of sight analysis? How to do course of action generation? How do I look at the enemy's most dangerous course of action, most likely course of action? All of these things that I'd say in some way we've been able to do algorithmically. Now, how do I take those tools and give it to the LLM so when the user is trying to ask a question like, I have to plan for Dunkirk. How do I find every cargo ship that's over 150 meters that's in this vicinity and build an operation around that actually 1 or 2 sentences replaces what would have been maybe 50 clicks. 1 or 2 minutes replaces what would have been 1 or 2 hours. And in those sorts of contexts, I think that's everything. Then extending that metaphor, how do I think about how my application can interact with other backend systems? Instead of having to get you to go to another UI or thinking about how do I integrate those UIs, actually, I can be coordinating this through the LLM and the backend by manifesting those other systems as tools for the LLM.